Hi everyone, my name is Snijders. I work for NTT Communications. And today I would like to talk with you about network automation. I know that Sweden has an almost religious fascination with manual labor, and this is expressed in the phenomena called IKEA. But I ask you that today you are open-minded to the idea of robots and computers doing the work instead of you yourself. Automation is interesting because to a lot of companies it seems that initially the cost to start automating is quite high. But I firmly believe, and so does NTT, that eventually the payoff when you automate something will be much better than if you continue to scale linear and do everything manual. There are many other advantages, not only time consumption, but also consistency. It is much easier to guarantee a certain quality of your product if you just have a cookie stamp that is applied instead of somebody copy-pasting behind a high latency link on the hotel Wi-Fi and some lines don't get through. So what we'll do today is I've asked some of my colleagues, John Heasley, also known as the author of Rancid, Troy Boudreau, Andre Tonk, who works for OpenDNS, now bought by Cisco, and Jared Mauk. I've asked them, what is your top 5 of things to avoid at all costs when you're automating? And what is your top 5 of things you should do when you automate? And I've aggregated those results, and this is the presentation. Hint 1. Do follow Unix principles. Be sure to make your programs and scripts compact and tiny. Do not, and I've done this myself a few times, do not walk into the trap that is this 10,000 line script that does everything from config generation to config deployment to validation. It becomes unmaintainable. If you follow the Unix principle and try to keep programs as small as possible, not only are they simpler to debug, but you can also reuse components in the pipeline. So in other words, don't try and modify Rancid to send out emails with blink tags and glitters. Just do that in a post-processing step that is separate from the config collections themselves. This is another one. Do not take shortcuts. Make no assumptions about failure modes. Try to identify all the failure modes, and if you encounter a failure, make sure that the automation program quietly backs out of the device and leaves it in a state that is not disruptive for your network. And one example of avoiding a shortcut is where you, for instance, assume that nobody will ever do a manual change on the device. If your policy is dependent on the fact that nobody can manually interfere, then down the road there could be a surprise if your program is confronted with the remains of manual labor on that device. Do buy good quality kit. Don't commit to a vendor without explicitly testing features that are necessary for automation. So do test all aspects of SNMP that are relevant. Use the CLI, see if the CLI is scriptable or whether it's some unpredictable garbage that some vendors like to produce. And ideally, ensure that it supports netconf. Because structured configuration is a far better approach than the CLI where everybody has a different flavor. Do input validation. And input validation is not only about whether something is syntactically correct, but also whether it makes sense according to business rules. One fantastic example from a few months ago, one of my coworkers, his left brain was in IPv4 world and his right part of the brain apparently was in the v6 world, because he entered as a router-to-router subnet an IPv6 address /30 instead of something else. And we had some, our automation just picked it up as, well, a /30 is valid in IPv6, and that was deployed. And suddenly we were originating the /30 that was that v6 block. I don't fault that person, I thought that our system accepted that on a router-to-router link net, a /30 for IPv6 was even possible to be configured. Another fantastic example that you often see in the default free zone is 2000:/6 or 2000:/12. Both of these most likely were people that forgot to type the last character and they actually meant to type up /126 or /64. But for instance, iOS will happily correct your input and put a /6 and a /12 on the interface. So not only we could blame iOS, but we could also blame the middleware that didn't validate, does this even make sense in the context in which this input is being presented. So do check not only syntax, but also context. Do lock down your automation systems. Do not allow for endless freedom and creativity. It is a very good thing if the users of your automation can only maneuver in a very narrow workflow, and if they want something special, then they should escalate to an engineering team that either builds the software to do that something special or finds another way to do it. But as long as you ensure that the majority of your automation system is very narrow in what it can provision for the end user, it will be easier for your users to use the system and it will be less fragile. Do not avoid training. Training and automation are often an overlooked combination. The thing with training is it's a two-sided sword. If you train your users, you engage them in using the automation and you can show them the benefits, which will make it more appealing for the user to actually use your automation software. If you don't train them, they're not engaged with it and they might find ways around it or not even be aware that now the automation can do this for you. So user engagement can be encouraged through training. Another part of training is if you don't train the users, they might, in all their innocence, start a script or launch a program that reboots the entire network. But because the script had some weird name, they're like, well, let's just see what this script does. Oh, I regret pressing enter. Training is very, very important. If you deploy automation systems, do spend time with your users, sit next to them, show them how the system works, and create manuals. When you onboard new employees, run them through the training. Do not disown the components that are vital to your network automation. I don't know how many of you work for gigantic corporations that like to create a lot of silos, where there's like system administration that has nothing to do with network automation and that has nothing to do with engineering. If stuff like your IRR local mirror or the DNS servers that manage the reverse zone or your Postgres database which contains all the customer data, if they are managed by different groups, it will be much harder for your engineers or your developers to quickly maneuver and improve on that. So be sure that the vital components are in the team that actually does the automation. Don't go full hipster on your network when you start with network automation. Be very conservative in which technologies you accept in your workflow and pipeline and which ones you don't. It should be a balanced choice, right? For instance, NTT uses M4 as a templating language. And M4 is that horrific thing from 1963, I believe.
78. How is that?
So on one side we could argue, well, it's nice that they committed to a technology and that's useful because people have that knowledge. But on the other side, maybe now it's time to consider different technologies like Jinja 2. Jinja 2 is now a few years old. It's an excellent templating language. It has proven to have a stable community around it. So that's a worthy successor. But other new stuff like running Docker on iOS XR I wouldn't touch it with a stick. What is the use case? And maybe 4 years from now, if that still is a thing, maybe then we'll consider it. Don't drop your pants when you do testing. And with that I mean, isolate your test environment from your production environment at a very basic level. Like you could almost air gap the connection. Because for instance, it is quite common to load your production database, a copy of that, into your test environment and then run through some tests. And it has happened on occasion that we emailed all the customers that their BGP session was down because the test box that run the software that does that kind of alerting was in the test environment, but it could not reach the production network. But it could email to the internet. Oops. So be very, and as we evolve as an industry where, not only we do SSH to devices, but we make API calls over HTTP, there's email, there's all kinds of interactions on all kinds of layers of the application stack. So physically disconnecting that part of your network from other parts of the network could be a smart idea. Don't agree to change management. Engineers know better than their managers when and how to deploy changes. I assure you that change advisory boards are the first ones to go against the wall when the revolution comes. Your engineers that write this network automation stuff, they amongst themselves must come to a consensus what their change management procedures are and how often they would like to release and with what kind of style. Should be their decision because they are building this and they are responsible for it. You can't have some pointy-haired guy going around just dictating to follow a process for the sake of following a process. Commitment is another thing I recommend when you do network automation. There are some companies that encourage their employees like, oh, that's awesome, you wrote this script in your spare time at home in unpaid overtime. Yes, it is awesome that the engineer expressed an interest in scripting some of the mundane tasks, but on the other hand, it is not a sustainable development style if you depend on accidental automation. So one thing OpenDNS did, and for them it was a big change in how they grew in their automation, is they introduced a concept, they called it Automation Friday. Their engineering team, I believe it's 7 people or so, they would designate one guy that would sit behind the computers to put out all the fires and deal with the tickets as they come in, and the other 6 people would focus only on network automation. So they would not be distracted by normal provisioning or other tasks. That was that one guy. And by having that firm commitment where the managers were like, yes, this Friday is entirely for you and automation, good luck. They grew in rapid paces. NTT has dedicated developers that work full-time on this stuff. So we created budgets not only in terms of money, but time. And if you don't commit at that level, if you don't have a buy-in from your management that says, yes, we will invest in automating the network, then it will be very, very hard to keep doing this. This is advice that I find hard myself often, is it's very easy to so an end user requests, hey, can you build this feature in the network automation system? And you go into the system and you think, well, I'm going to fix that bug or add that feature, but then you discover something is wrong and the light bulb is not working, so you go to the kitchen, search for a new light bulb, but you can't find them, so you go to the car and you notice that the car is not running properly, so you open up the engine hood and you want to try and fix the car, and then when your partner comes home and is asking you, what are you doing? And you respond, well, I was trying to fix that bug in that software, but somehow down the road I ended up fixing a car. That is a prime example of not getting things done. At some point I would say, separate refactoring your code or re-architecting how components work together, separate that from bug fixes, separate that from feature changes. So either code the feature or fix the architecture, but do not try to do both tasks at the same time, because you will never finish the product. Do clean up your code. If you notice that certain code paths are not used, just delete them. Do not regret it, do not comment it out like, oh, maybe that's something I'll use later. If it's unused, delete it. And one fine example is NTT has many templates that cover peer groups. And because we have various products and flavors in which we deliver the transit services. And because we use multiple vendors, we have Cisco, Juniper, we have to iterate through each and every permutation in that aspect to test whether the code changes were correct or not. So the moment we delete peer groups or peer group styles that are not in use or are associated with a product that's not being sold, we suddenly have far less test cases we need to iterate through before we can declare the code tested. So deleting stuff that is not in use can not only make your code more readable, but it can also save you time in terms of testing. And this one is tricky, because nothing is more fun than having a fierce argument with your coworker about whether Python or Ruby is better. And you might even end up defriending him on Facebook, and it can escalate, but it was a good time, you stood for something. You argue, Python is better.
Yes.
Don't go in that direction, especially when you're just starting with network automation and you need to sell it as a concept to your coworkers. You can always later on, because you use the small Unix program principle, swap out the programming language when the whole team agrees that indeed Python is superior. But when you start, don't make a fuss about it. If your colleague is like, yeah, let's do automation, you should encourage him, and if he wants to do that in Perl, okay, well, that's at least something. And it's fine if you draw the line at something like assembler, but don't make it too big of a thing what the choice of language is. Do steal ideas from your other teams in your company. It always surprises me that on the system administration side, we've done network system administration in an automated fashion for many years. It started with CF Engine, and then came Puppet, and now there's Ansible, and Chef, and Salt, and all kinds of cool stuff. And these guys have been doing it for years. Meanwhile, on the network side of the things, we're like, okay, John, which VLAN should I manually type this port into? It's weird. And we can learn from these people, because they've already dealt with issues like how to ensure that the state of a certain device is consistent with the administration, or how do you monitor, what monitoring practices, best practices should you encourage. So do steal from your system administration team if they already have automation going, because a server and a router are not that different in the end. We face the same kind of problems, except that Linux is nicer than XR. You should embed testing as an integral part of your automation workflow. Even if you start very simple, for instance, I've generated this config, the computer should now deploy it to the network. Is the config not 0 bytes? It has happened to everybody that has not done tests like that they try and deploy empty configs and thus wiping out the entire device. These checks are very basic. You may not know what the exact contents of the file are, but I can assure you, if the file is less than 10 bytes, something is wrong and an alert should be sent to a human. Another thing you can do is search for beacon strings in the config that is to be deployed. For instance, if you have an ACL that protects the control plane of the router, and in your security policies, something is described that the office IP address should have access to the control plane of the router, you could, in your pre-deployment check or post-deployment check, search for that IP address in the config. And if that IP address is not there, then you know something somewhere went wrong. So testing for strings in configs is a very good first step in getting some confidence in what is being deployed in the network. Do never delete log files. Log everything, put it on disk, and just don't bother with a retention policy. Just say the retention policies, we do not delete log files. And these log files should not only cover how the deployment of the configuration went, but also how the config was generated, what things were observed by the program that was generating that config. Every aspect, the syslog of the device receiving the automatically generated configs, all of that is required that if you end up in a situation somewhere where something went wrong, and your log files are the first place to go to try and see what the problem was, how it came to be. Disks are so cheap these days. 4 terabyte is like $90 these days. So any logging, just keep them forever. Do use version control systems everywhere. And by everywhere, I mean pre-deployment and post-deployment. How many of you here use Oxidized or Rancid as configuration backup? Perfect. So you're already accustomed to the concept of, at regular intervals, fetching the configuration from the device and storing that in a version controlled system. If you use an automation system that generates these configs and pushes it to the network, why not put that in a CVS as well? Because then you can compare what was sent to the device and how the device ended up storing it. For instance, iOS or Roque, they sometimes have a tendency that if you send commands in a certain order, how Rancid perceives them is in a different order. If you encounter some kind of bug, that kind of information can help you figure out why the config wouldn't commit. Use throttling in your network deployment. You can do throttling in 2 ways. One way, for instance, is to deploy to the network once a day. That means the cron job will never run more than once a day because you didn't configure it to do so. Or if you, and this was an example from OpenDNS, they have fully automated monitoring that verifies latency between all their endpoints. And if they notice that latency increases to a certain IP address above the acceptable threshold, a script will log in, shut down the BGP session, and it will automatically reroute through new paths. But of course, you wouldn't want a script to go bonkers and try to shut that session down 1,000 times a second. Maybe there's a bug in the latency detection mechanism, or maybe there's something else. But if you ensure that the script will never run more than, say, 10 times an hour, then even if there's a catastrophic failure in the monitoring system, if a device is committed only 10 times an hour, that is less of a risk than if it would go bonkers. So keep that in mind. Ensure that the computer cannot do endless amounts of changes. And this is a beautiful car from the 90s. This was the peak of technology when it came to cheap and affordable car building. But fast forward 20 years, it is not a modern concept anymore that if you enter a line of config into a device and press enter, that it immediately activates. It is very hard to properly automate around a device that doesn't have the concept of commit and roll back or roll forward. So be sure to invest in vendors that are friendly to automation, that support something that is of an atomic transactional nature, so you can send the entire config in one go instead of hoping that the lines will be pasted faster than the ACO is applied on the device. So iOS style devices are a no-go. Punish your coworkers that continue to manually configure devices even though you have an automation system in place. bypassing automation is like joining the Antichrist movement. It is bad. Especially, you know, we've all seen the Terminator movies where the computers fight against the humans. That is what happens on your network if you allow both to coexist. In NTT's network, everybody on the NOC has enable access on devices. We're not actively preventing them from making changes, but it is very well understood by everybody in the organization that even that enable access is meant for debugging, not for changes. For changes, we have an automation system in place. So make this message very clear in your organization. If you automate a certain task, never ever do it manually again. Do encourage testing, not only building those tests like we mentioned before to search for particular strings in your config, but enable your employees to replicate what is the production network and start the automation there. So if you deploy a certain line of Juniper and Mix devices, be sure to have at least 1 or 2 of those in your lab as well. Because you can't test on the production network. Well, you can, and it's arguably cheaper than maintaining a lab, but it's less pleasant for your customers. And not only get a copy of each device that you developed, also get test equipment like an Ixia or something that can spin up hundreds of BGP sessions, so you can you can do skill testing of your automation systems. Fortunately, most vendors offer very steep discounts if you tell them that the equipment is not meant for the production network, but is meant for training and testing purposes. Then they'll suddenly give you the best discount ever. Do proper data design, for lack of better words. And with this I mean, avoid duplication of data. For instance, if there's a particular domain name within which all the devices in the network operate, do not hardcode that domain name everywhere. Be sure to configure that, to set that value only in one location. So, for instance, when there is a merger and acquisition activity going on, and you need to rebrand your company, then you only need to update that one string, instead of searching through thousands and thousands of lines of code to see where that certain string is set. And avoid assumptions about data. Do not blindly accept or even hardcode as a conditional check that the domain name must be blah blah blah, and then this will happen because maybe you rebrand down the road and those assumptions suddenly fall over, even though that was not intentional. Who is familiar with this brutal cocktail? Warm mayonnaise and Jägermeister. That is what you get if you mix data and logic. And by that I mean putting data, like checking what the hostname is, in a template. So one great example could be, I have a template that generates the peer group and the neighbor policy, etc. And somewhere in my template, in the logic side, I have something like, if neighbor is NTT, then, and a blurb of config comes after it. But suddenly the relation with NTT changes, and you go from a peer relation to a customer relation, or vice versa, and you do not update your template to reflect the change in the business relation, then you could end up with a very awkward network configuration. So be sure to put the data in databases and don't put them in the templates in your logic themselves. Another example is if you hardcode the hostname of a device as a conditional check, like if hostname is router1 in Frankfurt, then blah blah blah. But suddenly you migrate all the customers to a different router that has a different hostname, then your template generation could fall over. So be very, very strict about this. Be vigilant about mixing data and logic. So this is my advice for you, and to encourage you further. If you have any questions you want to ask me in private, just send me an email or hit me at the bar tonight. And if you have questions that you dare to ask in public, have at it. It's your turn.
Okay, that was perfectly timed.
It's because of the NTP servers.
Of course. It's very dark in here. I'm not quite sure what happened, but I can see a question there.
Jerry, very good presentation. This is Walt from Hurricane Electric. Back in my former life when I was at Hotmail, the devs actually hard-coded IPs into their scripts and caused a huge outage. So, very good presentation. Thanks.
Thank you.
Great. Any other questions or comments or different views? You could have flagged when I was standing there.
To be prodded by cues. Yeah, I've wanted to do things like change, like a naming schema or a piece of, name of a piece of the nomenclature of a piece of equipment to possibly reflect more accurately the role it's doing. But unfortunately, I can't because it's hard-coded in some script over there that I have no control over. And basically the world will explode if I change this. It'll be like Alderaan when it's shot by the Death Star. If I change the name of a router. Boom.
That's a very unfortunate situation to have. I would just fly to the guy that owns that script and at gunpoint make him separate the data and logic.
I might use a water pistol, it's a bit...
I can hear it.
I might use a water pistol, it's a bit less aggressive.
Any other questions? Comments? Experiences? No?
All right, I look forward to talking with you later. Thank you for your time.
Thank you.